let's take a triangle and reflect it over a given line. So I've gone ahead and already graphed the triangle from the coordinates given to me. If you need to do that yourself, go ahead and pause the video and get those coordinates graphed. Otherwise, we'll just continue this. So they're going to give you the equation of a line or an axis that's going to act as our mirror line. So in this case, our first example, they've given us the line x equals 3. Let's graph that. You may recall from class, hopefully, that the equation of something like x equals 3 is going to be a vertical line. So I'm going to go ahead and count 3 spaces on the x-axis and draw that vertical line right down there. That's going to act as my mirror. And so we can see in this, because our image actually crosses over the mirror line, our reflection is going to sort of intersect or overlap this original figure. The first method that I'm going to show you for graphing a reflection is to do what I call just eyeball it. So for example, if I want to find the reflection of point A, I can see that point A is 2 spaces behind the mirror. So what I want to do to reflect that is count 2 spaces on the other side of the mirror. It's going to stay at the same level, but point A, and we'll call it A prime to indicate it's a reflection, is going to be there, 2 spaces in front of the mirror. So we just kind of eyeball it. That works really well as long as your mirror line is vertical or horizontal. Let's do the same for the other coordinates. I can see that point B is 2 spaces in front of the mirror, so I'm going to count 2 spaces behind the mirror to find where the image is. That's where B prime would be located to make everything symmetrical. And as you can see, when I connect these, our image will be overlapping with the pre-image. And then finally, point C is 1 space behind the mirror, so I'm going to count 1 space in front of the mirror and label that point C prime. If I connect to make the triangle, I can see that I did this correctly because I can imagine, this flipping over to make the reflection. I can see that I do have symmetry, so there's my image just using this eyeball method. Let me go ahead and show you one more example, although it's going to work out just the same way. We're using the same original coordinates. This time, our mirror line is going to be the line y equals 1. Y equals is a horizontal line, so let me go ahead and get that drawn in there. So this time my mirror is going to be horizontal, meaning my image should reflect downwards below this mirror line. Okay, let's do the same thing. Let's use the eyeball method to find our reflection. Let's start with point A. I can see that that's 2 spaces above the mirror, so my reflection is going to be 2 spaces below the mirror so that I have symmetry. So A prime should be located right about there. B is 1 space above the mirror, so I'll count 1 space below the mirror for B prime. And then finally, C is kind of interesting. You notice that point C is right on the mirror. If you imagine looking at your reflection in an actual mirror, suppose you were to reach out and touch the mirror, it would appear that your image is touching that same spot. I'd recommend you don't do that because then you're going to have a handprint on your mirror and it's going to be weird. But anyway, all that is to say that point C prime is going to be in the same location. If your point is on the mirror line, your image will be reflected to the same location. So there's going to be my reflected triangle when I use y equals 1 as my mirror line.